Welcome to the IoT Plus Coffee Break. We've got a great edition for you here today, which is the IoT applications within the industry or with industry, which is very exciting. We are joined by two fantastic speakers today. But before we dive into that, I thought I'd best introduce who I am and what I do, so you at least put a bit more context to who I am. My name is Taylor. I'm from Motion Lab Berlin, and essentially what Motion Lab is, it is a hard-tech innovation hub and makerspace, a big fancy description for what we do. Essentially, it is all about helping young hardware or hard-tech products go from idea to series production. So we do have a strong focus on IoT, and we support with a whole bunch of knowledge, network, machines, space, you name it. I suggest everyone just swings by the space themselves to check it out. But in addition to that, we are a proud member of the IoT Plus network, which not only allows us to benefit from such amazing talks as you are here today, but also from an array of different events. I recommend you give a shout out to Pavlo, who's actually also in the chat, or Jacqueline, to get more information on the IoT Plus network. That being said, why are we here? Well, we're here to hear more about two great speakers, namely learn from Angelo Bindi from the MES D.A.CH Verband. He'll be talking to us about manufacturing digitalization. So essentially a topic I think we all want to improve on, namely to improve our processes, increase productivity, and ultimately reduce our costs. Who is Angelo? Well, I mean, I've got a list here of all his qualifications and what he knows. It's endless. I think you best to describe what you do yourself. But in a nutshell, he has over 35 years of experience in assembly systems, production, plant engineering, and a whole much more. So you are going to be in the best hands of learning from him. And then we are also joined by Pavlo. Matiieshyn. Now, I might have butchered that. I'm really, really sorry, but please do correct me if I'm wrong. Well, he's joining us from all the way from the Ukraine. He's head of embedded development at Lemberg Solutions. Now, I don't know, Falco and Jackie, how you made this happen, but we've got two great speakers because he too has amazing experiences. And he'll be talking to us about predictive maintenance and how IoT or industrial IoT solutions can be implemented. We're talking to us about a whole bunch of use cases and basically also on how to improve our solutions. And he's got a few use cases, I think, planned there. How will we proceed? Well, each of our speakers will present themselves in more detail as well as their topic in about 10 minutes. This is then always followed by a Q&A, so feel free to write your questions in the chat, and then my colleague Jackie will unmute you and give you the floor to ask your questions. If that is all understood, I guess the floor is yours, Angelo. Feel free to share your screen and we'll get started.
Okay, thank you very much for the introduction. My name is Angelo Bindi. I'm the CEO of the MES, that stands for Manufacturing Execution Systems Association here in Germany. And in the meantime, after 11 years, we are the biggest manufacturing digitalization association in Europe at all, who is focusing on manufacturing execution systems, which is important. Yeah? As said, I have a couple of experience, a couple of years in different industries. And as you may hear, I'm still sitting again on a construction area where we built up for a relative known German manufacturer for electro vehicles, a new assembly line. And in the background, unfortunately, there is an alarm ongoing, which we could not switch off, which is annoying a little bit, but sorry for that, but I hope you could understand my voice and noise clear. Okay, let us start with digitalization for production processes or assembly processes. We did not see a big difference in that. The simplest question is how it looks like today if you are coming into existing companies, because if you are talking about the ideal solution and all the things, that simply means you are talking about new installation, greenfield installations, which is not really true, because 98% of the installations in industrial countries are brownfield installations. And so sometimes we need to take care about that as well. Yeah? In a normal case, you have a simple production line or a more complex production line or assembly line, which is controlled partially or fully by a PLC. And if you're lucky, you have a SCADA system above, you have a manufacturing execution system, you have an ERP system, you have a warehouse management, supply chain management system. And last but not least, if you are up to date, you have a web shop where the customer could simply configure or order products out of the web shop. Yeah? Controlling is mostly requesting a business intelligence system. And if you are in a lucky situation, you have a centralized database. Yeah? But all these parties want to talk together, and you have a couple of connections which you need to maintain. Most installation where we are coming for small and mid-sized enterprises, yeah, they're really ending at the SCADA system. ME systems, you know, the most sophisticated ME system in the world is for small and mid-sized companies. That's normally Excel. Yeah, that's how they do their manufacturing execution. So that means, last but not least, that you have N+1 proprietary drivers, which you need to maintain, yeah, which leads at the end of the story in the CEO or the company owner would like to have as well cloud-based things, because you have here that is a new way of doing things, yeah, and all the things lead into a lot of different interfaces which you need to maintain. But what in the end of the story brings you to the DevOps problem. That means how you could bring system from the development into the operational state. Yeah? And as you can see here in a small chart, even if you're connecting, you're not connected, your devices or your systems which you would like to connect together are increasing in a linear way. Yeah? The number of connections, if each system needs to talk with each other system, is increasing exponentially. Yeah? The next challenge which we see is a communication problem. Between the automation guys and the IT guys, they are both programmers, there is no doubt about it, but the automation guys mostly living in their automation pyramid, how we call that, which is, in my opinion, not valid anymore. The functions in the pyramid is still valid, but to see the pyramid as a closed monolith, it's not valid anymore. We need to have three functions, as a little bit more as on the right side, what you could see, how the IT is working today with modules and a modular system. Yeah? But at the end of the story, the automation guys and the IT guys, they talk together, they find solutions, but at the end of the story, the result is not very often leading into 100% fit. Yeah? What do we need for that? We need an architecture. And if you go to an automation guy and asking him which kind of architecture do you using for your system, he's simply asking you, what do you want? Yeah? And we are talking about the data architecture, the business architecture, the technology architecture, and the application architecture. And therefore, you need to establish a kind of scorecard which is valid for your special situation, so that at the end of the story, you did not have only an architecture, you need to have a blueprint, a drawing of that, what you would like to do, with all the details which you need to build this object. Yeah? But how you could do that? The ideal idea would be, if you have a production line or assembly line, you need something else like a USB with plug and play. And I'm not talking about plug and pray, yeah, which is completely different, connected to an upper system. And this system is connecting to the cloud on a bidirectional way and all the things. The concept is quite simple. you have your production line, then you have your, let me say, centralized data storage, aggregation, yeah, and at the top of that, you have not, let me say, physical systems, yeah, these are functionalities which you have, yeah, and if you embed this functions, software as a service, into the cloud, yeah, and simply looking to the functions again, not to the physical systems, yeah, you are talking about functions, yeah. On the other side, the middle point of that with the data storage, the aggregation, the processing of data, the navigation, yeah, the streaming of data should and would be done with an IoT system or IIoT system. Technology is never the question in projects. Technologies are there. We need to combine them in the right way with the right interfaces, yeah, and fitting to that problem which you would like to solve with that. As you see with OPC UA, TSN is a time-sensitive network that is a real-time Ethernet over OPC UA possibility to connect devices very fast together. You have different cloud providers. You have RESTful APIs, which is established since decades in the internet and is valid and proven. So you did not need to redevelop things again. Last but not least, the data storage. You have a couple of data storage possibilities already in place, yeah. So there is no need to redevelop things. You have Kafka as a streaming engine. You have Kubernetes as cluster. So again, technology should not be a hint for you to establish new solutions. Yeah. Solution possibilities are quite simple. Yeah. You have, again, your production line with a PLC. You have edge controller with native drivers to those PLCs. And in the edge controller, you have maybe an IIoT included, or you have an interface to an IIoT platform, whatever. Yeah. You could use for the cloud-specific things, infrastructure as a service, platform as a service, or software as a service. You could use OPC and MQTT, very established and robust systems. Yeah? So that could and should be the solution for digitalization in the production area for the future. Yeah? And all these things are available. You did not need to develop, you need to compose that. You need to arrange that in the right way, but that's all. Let me talk about knowledge against intelligence. Yeah, because a lot of people talking about artificial intelligence. Yeah? But knowledge is the ability, what you have learned, to put into a structured and systematic way. That means knowledge has a repetitive character. Intelligence is the ability that things which you know, so the knowledge itself, to combine with new, let me say, interpretations, yeah, associations, and deriving out of that new connections and all the things, which means intelligence has a creative character. Yeah? Artificial intelligence is the ability with a high amount of repetitions to come to a new knowledge. Yeah? But that means at the end of the day that the possibility to have a misinterpretation of data is very high, exactly as on a human being. Yeah? And that is artificial intelligence. Yeah? But at the end of the day, artificial intelligence is not a good choice for deterministic tasks, for example, calculation tasks. And artificial intelligence is not intelligence. It's primary a knowledge based on iterations, yeah, which means with a very high speed, we could iterate to different possibilities, yeah, and we could go through a huge amount of data, yeah, but the evaluation is, again, you have the possibility in the evaluation for misinterpretation because it's a repetitive thing. And that is artificial intelligence per definition. Yeah. So my point here is the most people have the wrong expectation about intelligence, artificial intelligence systems, yeah, because they are not taking into consideration that you need to give the systems time to learn. Yeah, it's exactly the same as in a human being. Yeah, so be patient at the end of the story. Yeah. Machine learning and deep learning, yeah, they are different disciplines in artificial intelligence. And if you look to the history of artificial intelligence, that is already established in the 1950s in the European world. And the machine learning and the deep learning comes much, much later. But artificial intelligence, yeah, that means the first application was already established in 1950. Yeah. The traditional programming approach is you have data, you have static code, and out of that static code, you have a result. Machine learning or deep learning later on is coming from data over algorithm to a hypothesis to a result again. And between the result and the algorithm, you have a continuous feedback loop, which optimize the algorithm step by step. That means if you have more information, you could learn faster, yeah? Which comes to, at the end of the story, to a net, yeah? A neuronal network, yeah? Which gives you the possibility to find very fast solution, to have a pattern for which you could search. What do you need to start? Yeah, with ME systems, digitalization, you need to learn, yeah, that you need time. Yeah, and machine learning need exactly the same time to learn as a human being. You need to have enough data and enough good data available. Yeah. Machine learn. It's a little bit more, has a little bit more a generic character. Yeah? You need to have what we have seen in different projects for manufacturing execution, digitalization. You need to have your own stuff if you want to continuously improve the models, the digitalization approach in your organization. You need to have your own people. If you focus only on external people, you have all your digital knowledge for your production on an external base, which is maybe not the optimal approach here. Yeah? And you need to be patient. Yeah? The first results of an ME system, of artificial intelligence, of digitalization, you will see not before 18 to 24 months after the first starting which you have. And after that 18 to 24 months, yeah, you have usable results at the end of the story. Yeah? Maybe you are wondering that I have till now not talked a single word about manufacturing execution systems, because all about manufacturing execution system, I told you before, we are acquiring, we are collecting data, we are aggregating data, we are processing data, we are distributing data to upper systems like the ERP or whatever. Yeah? But this is all part of a digitalization roadmap which you need. And before, so most customers are really wondering, when I come to a customer, in 99%, I clearly say, you did not need a manufacturing execution system now, which is very important, because you need to do your homework before. You need to have a digitalization strategy. You need to have your digital roadmap, where manufacturing execution systems is just one part of it. Yeah, like IoT is just one part of it. Yeah, but if you don't have the full picture, how you will build up a complete architecture for that? And that's the reason why the MES D.A.CH Association offers manufacturing digitalization workshops, yeah, together with customers. That's a 2 to 4 day workshop where we could give them a high level digital roadmap then if the customer want, he could continue with our partners, yeah, to do really projects in digitalization with a digital office, with an organization and all the things around. Yeah. At the end of the story, you need to have a value add for each user and each customer. Yeah? You would to be cost savings. Yeah? You would like to have an appropriate amount of resources which you need for your projects, for your production. Yeah? You would like to have a productivity increase. You would like to save your knowledge as well, especially if you have problems to acquire the right specialist at the right time in your business. Yeah, you could see new business models which you could implement with digitalization. You have a complexity reduction because you just maybe it's the wrong word, complexity reduction, because the complexity may be increased, but you hide that complexity with the right tools in front of the customer, so that the customer or the people who operate a production line just seeing the necessary or useful information which they need to make the right decision at the right time. And what we have more and more, especially in countries like Germany, where the labor costs are quite high, we see a dynamic, very high increasing of automatization of processes in any direction and in any industries. Yeah. So my question would be, or a normal case, if I have a presentation, I raise a question at the end of the day. And if you think, I don't give you the answer to that. And if you think about that, yeah, if you have the right answer, then you have maybe in 90% of the cases, you have the right way, how you would like, what do you need to change that you come ahead? So my question is why we have so less artificial intelligence systems in production areas or assembly areas today? That is my question. So thank you very much. And I think my time is over for today.
Yeah, well, thank you, Angelo. That was fantastic. So for those that just joined, well, on side note, there's someone that's decided to drill right now, so I hope you don't hear that in my background. But it's definitely a manufacturing environment going on here today. That being said, you are free to ask questions by just typing them in the chat, and then my colleague Jackie will unmute you or ask you to unmute so you can ask that. Angelo, thank you so much for giving us some insights into the digitalization within manufacturing. I do see that Janios, if I've not pronounced that incorrectly, has a question. Would you like to unmute yourself and ask your question?
Maybe he's a little bit shy.
That could be. On that note, I'll just faulty microphone. I'll ask your question then for you, if that's all right. I'll read it out loud. The question reads, how often LTE networking equipment is chosen for the IoT part when we are talking about manufacturing digitalization in comparison with other technologies like LARWAN, Sigfox, Internet, etc.?
It depends on the industry where you're looking for. If you are going for water supplies, electricity supply, and so where you have a lot of distributed, decentralized units around, then LTE will be used intensively, more and more 5G. Yeah. But on a normal production assembly area at company level, we are using wireless LAN and mostly wired Ethernet in terms of speed, which we need here. Yeah, and as you may imagine, real-time information where you have a real hard deterministic requirement. Yeah, so you could not use LTE or wireless LAN, so you need to be based on wire.
Well, thank you. I hope that answers your question. Seems by your reaction it does. Fantastic. Off the bat, Angelo, I actually have a general question for you. What do you see as the biggest challenge that German companies face when adopting such solutions?
find the right experts at the right time to do the right things.
So in other words, reach out to you.
No. You could do if you want, but I could not save the whole world. That's not possible. Yeah, I see really, especially in those technical areas, if you go to universities and all these things, less and less people are really willing, especially here in Germany, to go to technical disciplines, yeah, to go for informatics. They are specialized in automation technology. Excuse me. And these things, yeah. So that is really a problem. Yeah, we could do much more if we would have the right people at the right time here.
All right, fair point. So we need to educate within that field, then that's for sure.
Exactly.
Jackie, could you unmute Falco because he has a question for us?
I did, but it's not working. Falco, you can unmute yourself. There you go.
Yeah, I was muted immediately again, so that didn't work. First of all, thank you, Angelo, for that presentation and your insights. I like that you're saying like reach out, get in touch with people. That's what I usually also say. Like if you can't save the world yourself, you might as well get help doing so. I wanted to get into why maybe AI is not as prevalent yet. My hypothesis would be, not that I have any major knowledge on this, but my hypothesis would be that since AI needs a lot of data that is, as we say in German, Sortenrein, so that is classified and structured in a specific way. I always wonder how easy it is to actually scale and expand a artificial intelligence solution or an algorithmic solution in a production environment, because although we often think that production environments are very homogeneous, it turns out they're actually not. Many of the industrial manufacturing IoT companies that I've seen in my day have actually faced exactly this problem, where you think an engine is an engine, but it turns out that the engines are all so different that you cannot necessarily compare an engine that already has a couple of spare parts difference to another engine. They sometimes work differently, and I think maybe neural nets and deep learning has some way to go before you can generalize this out of production. What do you think?
Yes, sounds valid, your answer. Yeah, but in general, I think I have the impression that the people have fears to step into new areas, yeah, because sometimes the result is not really clear. They have an idea, but they did not know the result, yeah. And I think especially maybe that's a German attitude. They don't want to spend too much money and time into a thing which is maybe a little bit risky. Yeah.
So you would say it's the fear of the unknown, because that's very philosophical for the German industry, I'd say.
Yeah.
Okay, fair enough. Well, if anyone has the fear of the unknown, happy to help.
Yeah, if you compare simply the venture capital market in US with the venture capital market in Europe, not especially in Germany, because Germany is a little bit more conservative than the rest of Europe. Yeah, but if you compare it to Europe, that's completely different. So the US markets, they are much more willing to take risk as in Europe.
Very interesting. Thank you, Angelo. Axel, you still have a question there. Would you like to?
Yes, thank you. Industry is often a very regulatory and compliance heavy field, especially for safety. Has this affected the ability to try out new and innovative solutions in any way, or has it hindered that?
No, it has not hindered. Yeah, I think we have, due to new technologies and possibilities, we have innovated in the last years a couple of technologies, especially in the safety and security area, which would be not possible before. Yeah. So it is, technology is an accelerator, especially for safety and security specified activities. That's what I have recognized.
Very cool. Angelo, you did mention that you can find your digitalization workshops that you offer. Maybe you could share that in the chat for others then to tap into should they want to find out more about what you offer. But then also looking at the time, I think this is the perfect time for Pavlo to introduce himself and Lemberg Solutions, as well as the use cases in more detail. Thank you, Angelo.
So yeah, hi everyone. Do you see my screen?
Yes, we do.
Yes, thank you.
Yeah, okay. My name is Pavlo Matiieshyn. I'm head of embedded development at Lemberg Solution. I'm embedded engineer with over 10 years of experience. My main focus was hardware and software development. I participated in a lot of projects. Most of my background experience is handheld radiation measurement devices and radiation measurement instruments. I developed a lot of projects for critical infrastructure, military projects, and so on. My main focus at Lemberg Solution is hardware development, firmware development, IoT cloud integration, embedded Linux development, AI, and machine learning. Our company, Lemberg Solutions, is 15 years on the market. It has over 200 well-skilled engineers, and we delivered more than 800 projects for 300 customers. What else? I want to talk to you to what is predictive maintenance in industry and what are its benefits. So predictive maintenance is a technique that are designed to determine the condition of in-service equipment in order to estimate when maintenance should be done. Predictive maintenance is used in a variety of industries, and when you need to achieve high reliability of equipment, uninterruptible manufacturing, and highest safety levels. What it gives you, it give you a cost savings because you do maintenance of your equipment on demand. You have uninterruptible manufacturing because of less of unexpected machine failures, and obviously resource optimization, because maintenance team is doing what they should do, and on-time maintenance, because you can estimate when your equipment need to be repaired, or some parts need to be replaced. How it works? Generally, you have some kind of a piece of equipment. Here I have a simple motor, and how you achieve predictive maintenance? You simply place some kind of a sensor. It could be a thermal sensor, vibration sensor, acoustic sensor, and the impedance sensor on your equipment. You gather some data. You have acquisition module, which is collecting this data and could do some processing. You have some wireless gateway, and you just send the data itself or the results of the data processing to your maintenance team or other responsible staff. I want to tell you a little bit more about these sensors, which you can use for data collection. So you can use some kind of anti-seat thermistors or thermocouples just to monitor the temperature of your equipment, and when the failure is close, the temperature of this equipment will rise, or you will see that the temperature have some other patterns which are not which weren't available on when equipment was new, and you did not see that any such anomalies. Okay, so the next sensor is vibration sensors. So you can place an accelerometer on your equipment and measure vibrations, convert this data to the amplitude of vibration and its frequency, and on this pattern of different frequencies that are available on equipment, you can predict that something goes wrong and you need to do some maintenance or replace the equipment. The next sensor is an ultrasound sensors. So you mainly place this sensor on your equipment because your bearings are producing ultrasounds, and you can simply read this data, convert it to the frequency, and measure the amplitudes of this sounds. And the last sensor is an impedance sensor. It's a really interesting approach to measure the health of the bearings in equipment, because in this way your bearing works as a capacitor or as a RC network, and you just measure its impedance, and you can calculate if something goes wrong, this impedance decrease, because in this bearing you have inner ring and outer ring, and between these rings are balls of this bearing and thin film of oil, and in this way it acts like a capacitor, as I mentioned. And if the bearing is not working properly, this film will become thinner, and you will have a decrease in your impedance. Yes, so the next slide is about what sensors should you use for predictions. It depends. You may use all sensors, or you may use for if it's a critical equipment, you may use you may want to predict the maintenance as early as possible to try to help this equipment as healthy as possible. Yes, so for this purpose, you may use vibration sensors or ultrasonic microphone. And in this way, you will see a tiniest details of your equipment, and you will know as early as possible that something this processes started. They are started. So for other sensors such as temperature sensors or impedance sensors, you may use them later when the equipment should be replaced yeah, really soon, a week or two, probably months. Yeah, and in that way you may plan your maintenance work. You can order some kind of spare parts and plan this work probably to do as fast as possible, just to minimize the line halts and yeah, and other issues.
Pavlo, on that note, I see Thomas has just actually asked a question right there and then. Thomas, would you like to quickly ask that? Because I think it's on this topic right now.
Yeah, can you hear me?
Yeah.
Perfect. Yeah, I just wanted to know, I mean, are you also using then combinations of sensors, and which ones, like where you put, I don't know, vibration and temperature together? Are there other combinations where you say, well, these make sense, or are there different criteria to determine which if combinations make sense and which combinations?
Yeah, actually, it does make sense because one of our engineers used a vibration sensor and magnetic sensor on this huge cranes motors, because he said to maintain this motor you should climb really high. It's a really difficult work, and they placed this vibration sensor to determine the motor health, and this motor wasn't working continuously, and you should knew exactly that the motor is working, and the data is gathering exactly from the motor, and you can predict its health. And yeah, and also you may use this temperature sensor, so it does make sense to use a combination of sensors, because some spare parts are unique, and the time to manufacture them, it's really long, and you can when you use multiple sensors in one project, in one this combined sensor, you can precisely know that the process of degradation started, and you can order a new equipment to manufacture. And when a temperature sensor works, you know that, yeah, times comes and you have your spare part, and you can easily repair.
That sounds
Start process from start. Yeah.
okay. Perfect. Thank you, Pavlo. Actually, on that note, it seems the whole questions have started. Axel, you've got a question quickly. Now we're interrupting your presentation as we go, but I think it also is very fitting to the topic at hand.
Thank you. We found that the sensor reading and the kind of sensor profile that you see is often very specific, not to a model of a type of equipment, or even the specific installation site, which makes the configuration or training very complicated and costly, and also hinders scaling of predictive maintenance solution to bigger areas. How do you deal with that?
Yeah, it's true, because when you have a lot of similar equipment, yeah, it's easy to do your predictive maintenance, because you have a lot of data and you can do it. But when the equipment is unique, you should gather the data. It could last really long, and yeah, to do a good predictions, you should really get a long set of data, and it could be a problem. Yeah. So how do we deal with it? I don't know really, because it's a problem of our customers. We really just are doing a solution, and how this data are collected. Yeah, it's a problem of our customers. Yeah.
Okay, thanks.
Well, thank you, Axel and Thomas, for those questions. Pavlo, do you want to carry on?
Yeah, please. Yes, so yeah, here I want you to tell you about our use cases. So what we do for our customers, it was ultrasonic based device for rolling bearing condition monitoring. So for our customers, we did some kind of a prototype. We use for this Raspberry Pi. We use some ADC module board, and it was the board was running embedded Linux, and we write our program on Python. So on this slide you see our demo that we presented on Embedded World. It's a simple device. We had two motors, and the data were collected from both motors, and we compare this data and saw that one of the motor isn't working properly. Yeah, so on this slide you can see this our prototype, original prototype, which we delivered for our customer. Yeah, as as I described, so it's a Raspberry Pi. It's an ADC board, and you can see ultrasonic sensors and transducer. Yeah, so it was, yeah, it was really simple. It's a simple application, but it was available for our customer, and we did our job well. Also, we had a few requests from our customers on almost all the some kind of POC or other equipment from our customers, and they asked about vibration sensor and impedance measurement. So it's really really up to date, and these techniques of predictive maintenance really saves a lot of money. I see some numbers, and it said that last year the predictive maintenance saved over $17 billion in the world. So it's really nice. Yeah, so that's all. So thank you for your attention.
Thank you, Pablo. That was fantastic. Definitely also had some questions in the chat going on there. I encourage everyone to just read over that, as there were some clarifications that were put out. I do actually have one question for you. I mean, you mentioned $17 billion in costs that were saved due to predictive maintenance solutions. Do you see a specific type of sensor or use case that is more profound in applications nowadays, or is it a very general situation in which different solutions are used, or different types of sensors?
Yeah, you should use different types of sensors for different solutions. You cannot use some kind of unified solution, because everyone want to save their money, and some type of sensors are cheaper, so some are more expensive. Yeah, and it depends what you will do with this equipment. You just need to, is a repair of equipment should be done really fast, or you just replace the equipment. It all depends. because if you just want to replace your equipment, you may use some kind of temperature sensor and general microphone and listen and different sounds of your equipment. That's all. Equipment should be replaced, and you just replace it rapidly. But if you need to manufacture some kind of spare parts and some unique electronics and other stuff, it's probably better to have some kind of sensors that will predict machine failure much more earlier. And then you have time to order these parts, to deliver it to your warehouse, to prepare this maintenance, and it takes a lot of time, yeah, to do this. So, or you have probably some kind of safety equipment or other critical equipment. You have your production line going on 24/7, yes. So you should plan this work or maintenance really good, just to just to save costs, because line stops could cost you a really lot of money. Yeah, so.
It definitely sounds like a unique and uncertain situation, similar to what Angelo was speaking about earlier. And I can imagine also stands in the way of adopting such solutions, at least to the general masses at the beginning. Axel, would you like to ask the final question of today? Because can you believe it or not, an hour has already almost passed.
If there's anyone else, I don't mean to hog all the time, but
no, you've got a good question, so go for it.
Okay, great. Well, usually, the question was, do you work with the owner or the integrator of the equipment or the actual vendor? Because we found that the owner has the goal of saving costs for maintenance. The integrator, as they want to sell spare parts and service time, often they don't, and the manufacturer, they also want to sell spare parts. And predictive maintenance would make them sell less spare parts, or they're often not so cooperative, and the owner can't really do this without cooperation of either.
Yes, so it's true. We work with equipment, such kind of equipment manufacturer or integrators, because they want to sell you a solution which allows the owner of the factory to save money. And so to save money, someone shouldn't earn a lot from the spare parts sales. So it saves your money, saves your time. And I saw in the chat, it saves your resources, because you can have a smaller maintenance team, or your maintenance team can work more efficiently if there is a big facility. The maintenance team could really do other job, and you can plan this job really precisely.
Thank you.
Thank you, Pavlo. Doris, I see you've had a comment, or is it a question? We still have 3 minutes to spare, so now's your chance.
Hello. I only wanted to comment. I think Falco, we met 2 weeks ago, and I'm from the German Environmental Agency. And I only wanted to contribute that I think that sustainable maintenance is a very interesting tool, which is saving money, but also resources, because you're efficiently repairing, and really you're only doing something which is absolutely needed in the moment where it's needed. And so I think many companies don't see that it has a sustainable effect, and you should also take this into account, I think, because often it's said, what does digitalization contribute to sustainability? And I think there are some instruments like this, which are itself a very interesting instrument to say we are very optimizing the use of resources, material resources in this way. Thank you very much.
Most
Yeah.
definitely. Thank you, Doris. I think it's a fantastic topic, and I'm so happy to have learned so many insights from you, Pavlo, as well as you, Angelo. It's been great. The topics of digitalizing manufacturing as well as predictive maintenance is something that I think are unforgettable, unavoidable in our future. It's something that we have to continue, especially also, as Doris mentioned, if we're going into a sustainable future, as we have to do. That being said, we have run out of time. I do encourage you all to follow the IoT Plus network to also get the contact details of both Pavlo and Angelo, and to find out more about the IoT Plus network and where you can find out more about such topics in the future. I thank you all for joining us, and wish you a pleasant day ahead.